Now let's look at page 38 and 39. Pace 1133, the first trigonometry pace. We have what are called identities in trigonometry, and this is going to be, we're going to see a series of these. And they're going to kind of develop from using the Pythagorean theorem, where c squared equals a squared plus b squared. Sine, remember, is a over c. Cosine is b over c. They summarize that on the top of page 38, and they have the triangle to picture that. All right, and this is going to feel like geometry a little bit, okay, because we're making a statement and we're trying to prove something. So we're going to follow the statements down, but we're going to also use some algebra to solve it. So sine was a over c, and we're squaring that. Cosine is b over c square, and we're actually trying to prove what does that equal. All right, when we have a fraction times itself, a over c times a over c, we get a squared over c squared. B squared times b squared, or b over c times b over c, would be b squared over c squared. Okay? Now they have a common denominator. You see that? So now I can put a squared plus b squared together, put that all over c squared. And now let's think about Pythagorean's theorem. Do you remember that? Hypotenuse squared equals the sum of the square of the other two sides. So c squared equals a squared plus b squared. So since c squared equals a squared plus b squared, look what I'm going to do. I'm going to take this and substitute this in place of what it's equal to, the a squared plus b squared, which gives me c squared over c squared. What is anything divided by itself? Anything divided by itself. It could be 3 over 3, 100 over 100, c squared over c squared, it equals 1. Okay, so we have just proven this identity. Now that we've proven this, we can write this in a reference notebook and use it in future problems to solve and find a missing number. Let's figure out what this one is, all right? This one, we have the 1, but we're missing what it's equal to. So let's see, tangent is taking oats away. Opposite over adjacent. Taking oats away. So a over b, and that's going to be squared plus 1 equals, and we don't know. So this becomes a squared over b squared. Now let's write this as b squared, okay, over b squared, because anything divided by itself is 1. All right, so now we've substituted. Now, can we put it over a common denominator? Yep. A squared plus b squared. And what is a squared plus b squared? C squared. All right. So now I have c squared over b squared. Well, let's think about the relationship. What is c over b? Well, b over c is cosine. So what is the inverse of that? The c over b. And that would be secant. All right. So secant squared theta. If it was b over c, that would be cosine. And then this is the secant, so secant squared of theta. So now we have another identity. Tangent squared theta plus 1 equals secant squared theta. So actually I did for you the 1 on the top of page 39. It's kind of helping you fill in those blanks. Now they want you to do number 2, which is 1 plus the cotangent squared of theta. And they want you to show all the steps, and you're going to end up with cosecant squared of theta. All right? So let's think about what is cotangent. Tangent is opposite over adjacent, A over B. So cotangent is going to be B over A, okay? Let's get you started here. I'm going to let you finish this one because this is your homework for that whole page, all right? We'll call this cotangent. So cotangent is B over A, so let's write B squared over A squared, because we're squaring the cotangent. So B over A squared is B squared over A squared. Now we want this to be 1, so we want to make it A squared over A squared. Anything divided by itself is 1. Let's keep going, put it over a common denominator, B squared plus A squared over the all right, then make your substitution. You're going to substitute the C squared. And then what is C over A? Okay, so if you need to look back at your chart, you can see that. And then it's that squared, so now we can write. And they actually show you on the very bottom of page 39 that we should end up with cosecant squared. All right, cosecant squared. So at least you know where you're headed with it, okay? And we're just going to fill in the missing, one more step here, maybe one more final step to prove it. Now we have 3 Pythagorean identities, they're called. And you have those listed in the blue box on the bottom of the page. Add that to your reference sheet, and basically we just get to use this, all right, from now on. So turn the page, and let's look at page 40. Look at the top of the page. It says, suppose we know that secant A is the number 3. We can use the Pythagorean identity, tangent squared theta plus 1 equals secant squared theta, to find tangent theta. Well, here they're doing alpha, I'm sorry. That's the same thing. And in fact, they start with the tangent squared theta plus 1 equals secant squared theta. So that's an identity that we copied down from the previous page. Now we get to plug in 3 in place of secant, square that. 3 squared is 9. And then if you look, they're subtracting 1 from both sides to get 8. All right? And now you can see if tangent squared of alpha equals 8, you do the square root of both sides. And so the square root of 8 could be simplified, as it shows there, to be 2 square root of 2. Remember how to do that. But square root of 8 is that intermediate step. 2 pops out, and we still have 2 under the radical. All right, let me grab one of these here on page 40. They do number 1 for you. But let's talk about how they got that, okay? Because that is a fraction. I think the fractions are a little bit harder than the other ones. Let me erase some of what we have here. So we're going to say the cosine is 2/3. And we're supposed to find the sine. So actually we can use this one right here, this one that we have a box around. So we're going to say sine, and they're using delta squared, okay, plus, now we're going to plug in 2/3 and square that, and that has to equal 1. So what is 2/3 squared? 2/3 times 2/3 would be 4/9. Now we have to get a common denominator, 9/9. Subtract the 4/9 and we get 5/9. So sine, and then the last step is we do the square root of both sides. All right, and I think you can take it from there and see how they ended up with the square root of 5 over 3.